Today we will discuss the problem bottom view of a binary tree. So let's first understand what is bottom view. So this suppose this is our binary tree, some random binary tree I have taken for example. Suppose these are the nodes 1, 2, 3, 4, 5, 6, 7. So what is the bottom view of the binary tree? So bottom view exactly means that when we see the binary tree from the bottom, from this side, what is what are the nodes which we can see. So let's start from the leftmost node. So this is the leftmost line, and if we view the binary tree from here, what we can see is the node 4. Similarly, this is the next line, and what we can see from the bottom is node number 2. Now here, node number 1, node 1, node 5, and node 6 both are at the same level, right? So we can see either of them, right? We can see either of them from the bottom, either of 5 and 6. We cannot see one because one will get hidden behind 5 or 6, right? So suppose we have to take the smaller number, then we will take 5 here. We can take any one of the 5 and 6, but let's assume that if we have to take a smaller number, smaller of these two, then we'll take 5. Now when we come to this line, we can see the line, we can see the node 3. Similarly, when we come to this line, we can see the node 7. So here in this case, we saw that since one gets hidden behind 5 and 6, right? And 5 and 6 both are at the same line, basically, both will fall at the same line. So we can see any one of them. It depends on how we develop our solution. Suppose we want to show the smallest number, we will just have 5 here in the output, right? So the bottom view of this binary tree will be 4, 2, 5, 3, 7. Got it? How will we get this binary tree now? So the intuition here is at each line, right? These are the lines which I have marked, right? At each of these lines, we have to find which node is visible from the bottom, right? And suppose we assign some line numbers to these lines. Suppose this is line number 0. We'll start from the root and mark it as line 0. When we move to the left child of any node, we will decrement the line number by 1. Okay, so this line will become 0 minus 1 minus 1, right? And when we move to right child of any node, we will increment the line number by 1. So the line number is currently 0, right? It will become 0 plus 1 equal to 1. Similarly, for this node 2, if we come to the left child of this node, then this line number will become minus 1 minus 1 minus 2, because we are decrementing the line number when moving towards left child, and when we move towards the right child, we increment the line number by 1. So this line will become what? Line number minus 1 plus 1 is equal to line 0, which is same as this line, right? So that's why we say that 1 gets hidden behind 5, because both are at line 0. We cannot see 1 from the bottom. Now for line 3, if we move towards line 6, sorry, node 6, we have to decrement the line number by 1. So this line will become basically line 1 minus 1, which is equal to line 0. So this 6 also basically falls on line 0 only. I'll just draw this one more line here, right? And if we move to right child of 3, this line is will increment the line number by 1. So this line will become line number 2. So basically from starting from the leftmost line to the rightmost line, we have to find the node which is visible from the bottom. Correct. So line number minus 2 to line number 2, these are the nodes which are visible from the bottom. Rest of the nodes, like 1 in this example, gets hidden behind 5 and 6. Suppose here we have one more node, say 8, and one more node like this 9. In that case, 9 would be visible from the bottom. So instead of 7, we would have 9 here, right? So hope you have understood how the solution would be developed. So for this, we will be using level order traversal. So we will traverse the tree in a level order fashion, right? And first we'll visit level this root level, then this level 1, then level 2, and so on and so forth. But the thing which we have to keep in mind is while doing the traversal, level order traversal, we have to store the bottommost node at each line. Okay. So for level order traversal, we know that we will need a queue, which will basically this new queue will have we will declare it as a pair of node pointer and integer. So this integer, right? This integer will store the line number for this particular node, right? For each node, what is the line number that will be stored in the integer variable. And apart from that, we will need a map of int type int comma int, and which will store the bottom node at each line. So this key will be the line number for this map, and the value will be the node value. So at line number say -2, the node value will be what? 4. At line number -1, the node number will be 2, right? Because here we have 4 at -2 and 2 at -1, right? And so on and so forth for the remaining lines. Why are we using a map instead of unordered map? Because in unordered map doesn't have the sorted list as per the key value, right? But map is sorted as per the key value by default. So that's why that's why we will be able to print the value starting from the smallest line, right? Smallest line number, that is line number -2, to the largest line number, which is the highest line number, which is line number 2, right? Because this will store the map will store the keys in a sorted order. Otherwise, we will have random values here and there. Suppose first, if we use unordered map instead of a map, if we use unordered map, then what will happen? It will not store the keys in ordered fashion. Then suppose we can have line number 0 first, then line number 1, say, then line number -2, and any random order, the line number values will be stored. So that's why we want to use a map here. Okay. Now, yeah, let's head towards the code for this problem. So for this, we'll use this platform. Let's again go through the examples given in the problem statement here. So for example, this is the binary tree 1, 2, 3, 4, 5, 6, 7. So what is the output of this? 42637. 42637. How they have taken it? Let's again go through the problem statement. Looks like the problem differs a bit from what I explained just now. Given a binary tree, print its bottom view from left to right. Assume the left and the right child makes a 45-degree angle with the parent. A binary tree is a tree in which each parent node has at most two children. A node will be in the bottom view of if it is the bottommost node at its horizontal distance from the root. Okay. The horizontal distance from the root from itself is 0. The horizontal distance of the right child of the node is 1, and the horizontal distance of the left child of the root node is -1, right? This is similar to what I explained. So if we come here, then the root is at horizontal distance 0, the left child is at horizontal distance -1, and the right child is at horizontal distance 1. So this is what is mentioned in this statement. The horizontal distance of node n from root is equal to distance of its parent from root plus 1 if node is in the right child, and similarly for the left child, the distance will be parent -1. That's okay. We already seen that. if more than one node is at the same horizontal distance and it is the bottommost node for that horizontal distance, including the one which is more towards the right. Okay, we have to include the one which is more towards the right. So in the previous case, we have taken 5 here, assuming that we should have taken the smallest value, but the question says that we have to take the value which is at the rightmost side. So at the rightmost side is 6, right? So we have to store 6 here and return 6 in the output. So that's what the question says, right? So for that reason, if we come down, we see that, okay, here the output will be 42637, right? The output is 42637. Now let's see how will we handle this case. Like we have to take the rightmost value, right? So for that, what we can do is, I think we need not do then there is no extra logic required for this, for handling this thing, because in level order traversal we will iterate from left to right, correct? We'll iterate from left to right for, so as in suppose in that case we will we will encounter the leftmost uh, node first, correct? The leftmost node is 5 here, which is visible from bottom, and the rightmost is 6, correct? So if we keep inserting values in the map as and when we find the bottommost node, that logic will itself suffice to handle this case, because the right child, sorry, the right node will always come after the, will always be encountered after the left node. Okay, so let's go ahead and write our solution. Let's see the constraints first before writing the solution. So where are the constraints? There is, yeah, these are the constraints. So test cases can be maximum 100. No number of nodes will be between 1 to 3000, and the data will be 10 raised to 9 minus 10 raised to 9 to 10 raised to 9. So basically we can use integer variable to store all this data, and what we have to output is vector of int. So let's declare a vector answer of type int. If we'll just handle one corner case, if root is null, just return the answer, empty vector. Now let's define the queue point having the pair of node pointer and integer level, and we'll also have a map of type int comma int, and this will store the bottom nodes. We will push the root element along with the line number. Line number is 0 for root, as we saw in the example before. Now we will iterate until the queue is empty. So we'll be doing a level order traversal now. So first we will take out the front node of the queue and the line number at which the node is. Then we will pop the element from the queue. We will simply insert the current node's value in the map which we have. Now we will basically visit the left child of the current node and set its line number to line number -1 as given in the problem statement. And when we visit the right node, we'll set its line number to line number current line number +1. So this is the level order traversal done now. Now we will iterate through the bottom nodes map, and in our answer vector we will push the nodes, bottom nodes which we have visited, and return answer. Let's go through the problem. Let's go through the code to see if there is any typo or anything. Root is null, return answer, q pair tree node and pointer, and q map and then bottom nodes, q dot push root 0, node empty, renode end pointer, q dot front dot sec first, and line number q dot front dot second, q dot pop. This looks fine. Let's run this. Oh, what is the problem? Tree node was not declared in the scope. Okay, this is binary tree node here. My bad. Okay, and this is data. Sorry, there is some minor changes in the tree structure. So all the test cases are passed. Now let's submit this. Yes. So we have passed all the test cases. And now let's discuss the time and space complexity. So the space complexity will be big O of n for the queue in the worst case because it will store all the nodes of the binary tree, and this map will also store the store all the nodes of the binary tree. So the space complexity for this map also will be big O of n, and apart from that we are not using anything. So the total space complexity is big O of n for q plus big O of n for map is equal to big O of n. Now let's discuss the time complexity. So the time complexity for level order traversal is big O of n because each node is visited exactly once. So this while loop and basically at each in each whenever we visit a node, we insert that node in our bottom nodes map. So inserting in the map will take uh, log n time, where n is the number of nodes or elements already present in the bottom nodes. So for in the worst case, the time complexity for inserting will be big O of log n. So total complexity, time complexity for this while loop will be n into log n, and for this for loop, the complexity will be or big O of n because there are n nodes in the bottom nodes map and we are iterating through it. So the total overall time complexity for the program will be big O of n log n plus big O of n, which is basically equal to big O of n log n. So hope you have understood the solution. Please comment down below if you have any doubts. Thank you for watching this video.